Yeah, dear students, today I am going to explain and show you the demonstration of string Meldes experiment. This is a Meldes experiment setup, and this is a tuning fork. You can see the tuning fork here, which is a heavy and big tuning fork, which will be oscillated with the help of electrical energy. So this is electrically excited tuning fork. To do that, we have here a setup containing a DC power supply. This is DC power supply, okay, and you can set the voltage also. I am setting the voltage knob. You can change this. I am keeping the voltage at 8 volts input DC, and from these two inputs I am taking them, connecting to a energizer circuit containing a coil. Here if you see it, this is the coil which creates magnetic field, and okay, and this magnetic field, the magnetic field, because of this magnetic field, this electrically tuning fork will be attracted and left electronically. So therefore it starts vibrating. So we want to calculate now what is the frequency of this electrically excited tuning fork in both longitudinal mode and transverse mode. So if this prongs of the tuning fork are vibrating like this is the direction of propagation, therefore we will get longitudinal mode. If I turn it like this, prongs vibrate like this, but the waves will be in this manner, so I'll get transverse mode. So we will do this experiment both in longitudinal mode and transverse mode. This is electrically generated excited tuning fork with a setup. Here I have a setup 8 volts. Now I am keeping this in this between the tuning fork, prongs of the tuning fork. This is the tuning fork, and this tuning fork will be, okay, I am fitting this exactly in between here. And while doing it also, we have to see that this coil should not touch the prongs of the tuning fork. Okay, it should be exactly at here. This is the current comes up to this. If I make this gap between these two as small as possible, there is a spark between that. Once there is a spark, this tuning fork starts vibrating with certain frequency. So what is that frequency? We have to find, and that will be the tuning fork frequency of the tuning fork. And to know that, the experimental setup contains a string here, a thread, and I can adjust the distance from here to here, and I can measure the distance by help of a scale, the total length of the thread from here to here. And you see, to create a tension in the thread, I am adding a pan to it. In the pan, you have to add some mass to it. Therefore, there is a tension T equal to mg. So when you take tension T is equal to mg, we take everything in CGS system. This is actually 10 grams. This is 10 grams weight, and the pan itself is 15 grams. So total tension that is there in the string is T equal to mg, means m the mass of the pan plus mass attached to the pan. Therefore this is 15, this is 5 grams, sorry, this is 5 grams. 5 plus 15 is 20 grams. So I am now taking and keeping this with the tension, okay, and you have to see that this should not touch anything, it should not also touch, okay, all this. So I am keeping here, this is now the pan where we have 15, and I am adding 5 grams to this. This is 5 grams, and see that, okay, this is at rest. Initially this is at rest. Now total mass attached T, okay, m is 20 grams, and I have to measure the length from here to here, but not now. After adjusting this distance, well, this is vibrating. the vibrating energy in the form of wave goes from here to here, and here I have a fixed point, here I have a fixed point. Between these two fixed points, I get loops with a nodal points here. So we'll get a stationary wave pattern between these 2 points. To get that stationary wave pattern, I have to adjust distance, because you know that when I have 2 fixed points here, these are 2 fixed points. If I fix a string here, the string will vibrate like this, okay, and having here. And after the wave goes here, because it is fixed distance, comes back, goes here, and comes back, and goes here, forming a stationary wave pattern containing loops. So we have to count how many loops are there. If this is the L distance, okay, and each is lambda by 2, we can write L is equal to N into lambda by 2. And this L, you should adjust the distance between these two, you should adjust that it must be equal to integral multiple of lambda by 2, where N take values 1, 2, 3. So therefore, how many loops I am getting, I have to calculate it. This will be happening only when you adjust the proper distance between the two ends, which is equal to L is integral multiple of lambda by 2. Thereby lambda you can be calculating. In addition to that, we know that T equal to mg. Here m we are taking in grams. How many grams we are adding? That is the total mass, means mass attached to the pan plus mass of the pan we have to take into consideration. G will take it as 980, not 9.80, because it is CGS system. 980, okay, I'll take meters per second square is the G value. And now I have to do first I'll do this experiment in longitudinal mode. This is the tabular form you can see here. Longitudinal mode, frequency n equal to 1 by root m into, okay, root t by L hertz, where t is the tension added. T is equal to mg, you can calculate. And L is loop length, how many loops I got, and what is the length of each loop I have to calculate by doing the experiment. And m is called the linear density of this thread. Okay, what are the thread you are seeing? This is the linear density. To measure it, I take 1 meter of thread, I wind it, I loop it, and I'll make the weight of that with the help of a balance. And therefore, linear density of the thread is nothing but, okay, the mass, you can see here, linear density of the thread is equal to mass of the thread by total length of the thread. So mass you can calculate by using a common balance, and length you can measure by help of a scale. And thereby that will be, in this experiment, the thread whatever we are using is having a linear density m equal to 0.0017 gram per centimeter. This you have to make a note of it to do the calculations for frequency, since the frequency formula for longitudinal mode is n equal to 1 by root m into root t by L. When you are taking root t by L, this will be taking an average value from the experimental values, that is from the tabular form. Now look at the tabular form. Load applied, here we applied 20 grams of load, and you have to calculate tension T is equal to mg. M is small m I am writing here, and this is load applied plus mass of the pan plus pan. This is 20 grams. So the equal to mg I'll get. Now after doing the experiment, I will see how many loops I am getting. To get the integral multiple of loops, we have to adjust the total length of the distance between the two ends, that will measure with the scale, and then how many loops are there. So if I want to know the length of each loop, I will divide this L by number of loops. This one loop, second loop, third loop. How many loops I am getting? So that if I divide this, okay, with this distance, I'll get the loop length of each loop. That's why what is length of each loop. Then you know T here, I find root T. and I know L from this column, I'll take root T by L. So I'll take three different values, maybe 20, 25, 30. So I'll make it 25, 30, three readings. Okay, for longitudinal case, each time you can calculate it. By doing the experiment, you can get these two values and you can calculate a loop length, that is length of each loop. Root T you can calculate, root T by L you can calculate from these two. And thereby you can calculate from here the average value of root T by L. I want this. This root T by L average you have to substitute in this formula to get N value. So we don't substitute each time. After doing the experiment, you have to find the root T by L for three different values and make the average. And this average should be substituted here with known value of the one. So therefore, this is the tabular form given in the value T equal to. So if I write capital M, I'll write capital MG. If it is small m, okay, but this is the load applied means load attached plus pan mass. Okay, this will I'll take and calculate the values like this. Now I will show you how to do this experiment. So come here. This is the experimental setup. You can see it. Now I switch on the power here. So this is connected here. We have AC supply and the power is coming, and this is called battery eliminator, which converts AC to DC, and then I switch on the supply. Once it is switched on, you have to keep it minimum 8 volts. Don't go beyond that. Okay, so I kept it now. Now come to here. When I am coming it, I am just adjusting this knob slowly. So I adjust this to get a spark. Okay. I take it here, I adjust this to get a spark. Okay, so once I get the spark here by adjusting this, okay, you can see the sound also. Okay, so this is vibrating. As it is vibrating, this is a fixed point. The wire is, okay, the energy is going like this, and this is another fixed point. I have now loops. See, this is one loop. Okay. This is second loop, and this is third loop. These are the fixed point nodes. These are antinodes. Okay, so antinodes are having. So I have now 3. These are the values. Okay, so I got 3 loops. To measure the distance, I take a scale, I switch it off. I take the scale and measure the distance from here. Okay, this is 1 meter from here, and I take it here. It is again something like 18 or 20, so total is 118 meters. Therefore, I will write the reading from this experiment. Okay, so see this. Whatever we got for 20 added and upon mass, you have to calculate the tension. I got 3 loops. Okay, I added 3 loops, and length of the thread from there to there I got 118 centimeters. 118 centimeters. Loop length you have to calculate by, okay, dividing 180 by 3, and then you have to find out root 3 and then root T and T by L from this. You have to do the calculations. Now I change the mass added in the pan. Now instead of 5 grams, I put 10 grams in it. Then 10 plus 15, 15 is the mass of the pan, total will become 25. So I add now. So this is now I am taking 10 grams of mass. Initially 5, I have removed the 5. Now I added 10 in this. I have added 10. And this is the system, whatever we have. Again, I switch on the power supply, and this is the power supply I am adding. I switched on it. And then we have to get a spark here. So I am slowly adjusting to get the spark. See the spark. and see the okay. So, but you see here it is not there exactly. Therefore, I move it distance. I change the distance. So, how many loops I am getting? I change it. I change the distance. Okay. Now look at this. I have changed the mass attached in this. We kept 10 grams plus pan weight 15. Now it is 25 is the mass attached, and then I have adjusted the length. We have two loops. You can see from here one and going here up to this first loop, and we have here second loop, and still it is longitudinal mode. So therefore, okay, I write here we have 25 but two loops only. The distance I have to measure it by switching off this one, but anyway I am taking roughly this as 100 centimeters. I take 100 centimeters. Okay. Now I will do the experiment. I will repeat it by taking 30 grams in the pan. Then I will see how many I will get loops and what is the distance occupied by the loops. Okay. Now see, this is 15 grams. Initially this is 5 grams, this is 10 grams. So total is 15 and pan itself is 15. So I am adding 15 plus 15, 30. 15 plus 50, we are getting that. Okay. So again I switch on the power and switch on the power, get this spark, and I have to see adjust the distance. I am adjusting the distance to get exactly because it's going beyond that, and I can see the distance by changing the distance. The loop must be clearly formed with a good amount of amplitude here. You can see the good amplitude here. Okay, this is the value I am getting the loops, and I have changed the distance. Now I find there are two loops, but the distance is now from here 1 meter. Okay, I switch it off and I measure the distance, and I take it this as 1 meter, and from here I have additionally 8 centimeters. So I have 108 here. So I will write now only two loops I got, and distance is 1 okay, yeah, 116 I write it as 116. So loops are 116 centimeters. So this is now 1 meter from here, and this is 16 centimeters extra I have taken. So therefore it is total is 116 for this. So we have the values here for 23, and of course this is for 25 too, but this is 110. Sorry, this is 110. This is 110. So therefore we have 20, 25, 30. Loops are 3, 2, 2, but the distances are changed as 118. Okay, we got it as 110 and 60. And you have to find out length of each loop. How to get length of each loop? If you divide the total length by number of loops, I'll get the value of one loop. Therefore, this I am calling it as y. If I divide by x, I'll get y by x is equal to L, that is length of each loop. Likewise, 3 I calculate. I find root t and root t by L. Substitute the average root t by L here, you find, okay, This is the formula for longitudinal, that is 1 by root m into root t by L, where m is the linear density of the thread, which is given as 0.0017 gram per centimeter. Therefore, you can calculate this. Next, we will do experiment for transverse mode. When I do transverse mode, the formula is, now if you see it, 1 by 2 root m. Here is only root m. Here is 2 root m root t by L. Again, I will do the same procedure to find out the loop lengths. The table is same, that is load applied, tension, number of loops, length of the thread, and then length of the each loop, root t by L. Again, I do the same calculations, but the formula is changed. But in case of transverse, you may not get good amplitude as you have got the amplitude in longitudinal modes. Therefore, now I will do the experiment by turning this in this form. I move this here. So if I move it, this is vibrating. Okay, I'm keeping straight away. Now the prongs are vibrating like this, but they are like this. So vibration is this way. The prongs will vibrate like this, but the loops are like this. Therefore, they are transverse to the direction. Hence, we call it as a transverse mode. In this, again, I'll keep it at 8 volts. I just switch it on, and I have to find the number of loops. If the loops are not formed, you have to adjust the distance. Again, I will do this experiment with taking 20, 25 and 30 grams. 20, 25 and 30. And I have to find out how many loops and what is the total length from this part to the end of this part. So we start with 20 grams. I just remove this 10, and 5 plus 15 is 20 grams add. So I keep it here, I keep this here, and it is at rest. Now we have to start doing this experiment, and by switch on this, and I keep this a spark generating. Now I have to adjust the distance. When I am adjusting the distance, you can see how many loops you are getting in. Now look at this setup. The transverse mode, we have now loop 1 here, we have loop 2, loop 3, loop 4, loop 5. 5 loops are there. Okay, total number of loops that are there. So if you want to get a stationary one, you have to slightly adjust this distance, so you will get the loops. And now I have to measure the distance of the thread between the 2 points. So therefore, to do it, I switch it off. I measure the distance from here. Okay, this is if I take from here, because this is somewhere here. So this is 100 centimeters here. 100 plus, if you come here, of course, this 100 plus 1, 105, 105. So total is length is 105 centimeters. So I write here this value as 5 loops I got for 105 centimeters. Then again I change into 25, I find the loops. Yeah. Now look at this. We have changed the mass attached. Now the mass attached is okay, 15 plus 15. 5 plus 10, 15. 15 plus 15. Now the value is 30 grams added together with the pan mass. Now see this. We have one loop, second loop, third loop and fourth loop. So we have now 4 loops. So you can see the 4 loops. First loop, second loop, third loop and fourth loop. Now I have to measure the distance. To measure the distance, I am switching it off. The length I have to measure it. Length of this, if I measure from here, it is less than 1 meter. So if I say here, okay, from here if I remove 4, okay, it is 96. So from here I just take it, it is 96. 4 I have to remove it up to this. So 96. So therefore I enter the values here. For 30 I have not done. For 25, 30. So I add 4 here, 4 loops. This is 96. Again you have to calculate root t and root t by L. Then now we will do for 25 also. Yeah. Now look at the mass. Mass is 10 grams plus pound is 15. The total is 25. Now look at this one. If you see it, there are 1, 2, okay, 3, 4 loops are there. 1, 2, 3, 4 loops are there. So now I have to measure the this length of the thread. 1, 2, 3, 4 loops are there, and I need to measure the distance. So this distance is roughly from here to here is 1 meter, and this extra is 1 centimeter. So 101 is this one. So 25, I got 4 loops, and here we got 101 centimeter. Then thereby you need to do calculations. To do the calculations for transverse mode, the formula is n equal to 1 by 2 root m into root t by l. Again you find root t by l here and take the average root t by l. Okay, substitute in the formula. So in both the cases you need to take the you need to take the values of mass attached, number of loops occurred, and the distance between the two node points, and therefore calculate tension T, then length of each loop. You know T, you find root T, and you know L, find root T by L, take average both for longitudinal and for transverse. And this average value should be substituted in the formula as root t by L here also. In longitudinal we have 1 by root m only, but in transverse we have 1 by root 2 root m. M is already given, so calculate it. Therefore result will be the frequency of the electrically excited tuning fork in longitudinal mode, in transverse mode. You find it out and tell me how much you are getting. So make a note of these values and do the calculations.